So we're going to continue today with section 5. We're going to talk about three things. We're going to talk about minimum and maximum values. We're going to talk about average rate of change, and we will talk about odd and even functions. Okay? So, first of all, a point, okay, minimum and maximum. Maximum, you think of what? The most. Minimum, you think of the least. So if we are talking about a graph, the maximum would be like the highest that our graph goes, right? The minimum, the lowest our graph goes. Now, when we talk about relative minimum and max, it doesn't have to be the absolute highest or absolute lowest, but we're talking about where our curve is switching directions. Where is it going from increasing to decreasing? Where is it going from decreasing to increasing? Where are we switching directions? Those are going to be relative minimums or maximums. So I have a curve up here that we're going to look at. If you want to type it into your graphing calculator, you can. Okay. I'll actually. Nope. Stop it. Okay. Did everyone get what they needed to down? Okay. So I will show you that when you look at these problems, okay, so I'm going to type in x times x minus 2 times x plus 3. Okay. Your calculator, okay, so first of all, let's look at this graph over here. How many times does our function change directions? Twice. It changes directions here and it changes directions here. So this is what we would call a relative maximum. Okay, and this is what we would call a relative minimum. All right. You're going to get some homework problems that ask you to identify the coordinates. Okay, so if you don't have your graphing calculator yet, you're going to have to just kind of, you can either like find an online graphing calculator or skip those problems if it asks you to graph them. If you have your graphing calculator, what you can do once you have it graphed, you can hit this trace button and you can move along the curve to kind of try and figure out where that that point is. Okay, so this is around, it's like around -1 2/3 8. Okay, and then you could toggle over and figure out where this point is. We're only going to be able to approximate. We cannot find the actual value until we get to calculus. Okay, so this is something where you get to play around with your calculator. Okay. Biggest thing is understanding though, when we're going from increasing to decreasing, we have a maximum. When we're going from decreasing to increasing, we have a minimum. Okay. All right. Average rate of change. When you hear rate of change, what do you think of? A line, and what specifically about the line? The slope. When you hear rate of change, you think slope. Okay, so we're going to talk about average rate of change. We can't really find slope per se of a curve that's not a line, but what we can find is the average rate of change. The average rate of change is the slope of the secant line of 2 points on a curve. Okay. Secant line. What is a secant line? says it up here for you. What's a secant line?
It intersects the functions at 2 points.
Okay, a secant line hits the function at 2 different points. Okay, a tangent, just like a circle, a secant line went through it twice, a tangent line hit it once. Okay, a secant line is going through our curve at 2 different spots, and we're going to find the slope of that line. Okay, so if you need a picture here. Okay, I have the red curve up here. Okay, it's not linear, we can't find slope, but if I draw a line through it, it hits it twice, and I can find the slope of this blue line, and it would represent the average rate of change between these 2 points on the curve. All right, so we're going to do one example. All right, we're going to ask for the average rate of change. Okay, that rate of change should be that trigger that you're going to use the slope formula. What is this right here? This is just the slope formula, isn't it? Y minus y over x minus x. The only difference is f of x instead of y, but they mean the same thing. Okay, so all we're doing is finding slope. Okay, so here we have the curve x squared minus 2x plus 8. Okay, this is our curve, and I want to find the average rate of change between 1 and 5. Okay, so average rate of change means we need to find slope. What must I know before we can go ahead and find the slope of that secant line? We have x is 1 and x is 5. What else do we need, though? Okay, we need the function values. So, help me out. What is f of 1? Okay, I heard 2 different values.
4.
1 minus 2 plus 8, right? So, okay. F of 5? 23. Okay. So, we're on a parabola here. Our parabola doesn't have slope, but the average rate of change is represented by the slope between these 2 points. So, our average rate of change, we're going to find the slope between these 2 points. So 23 minus 7, y minus y, over 5 minus 1, x minus x. So what does that give us? Gives us 16 over 4, right? Which is 4. So what's happening, we just found the slope of that green line right there. All right, last topic, even and odd functions. Okay, all functions are special because they have the relationship where each y is assigned a unique x value. Okay, so functions are special as it is, but some functions are even more special. Okay, right now we're going to talk about the case when they are even and when they are odd. Okay. So I want to talk about this second bullet first. An even function means that we are symmetrical to the y-axis. Okay, so if we have symmetry along the y-axis, we have an even function. Okay, I just drew a picture of a graph that is symmetrical about the y-axis. Okay, this is an even function. All right. Algebraically, it means that our f of x would be the same thing as f of negative x. Okay, let's talk about why that is. If I have a point right here, xy, then we have that same point reflected where? Where would it go? If we reflect about the y-axis, it becomes what coordinate? Let's keep it in terms of x and y. If I have xy and I reflect it about the y-axis, over here, it is what coordinate?
Negative xy.
Negative xy. Okay, so x and negative x have the same y value, which is why we have this. X, when you plug it into the function, should get you the same thing as when negative x gets plugged into the function. You will have to identify even and odd functions graphically and algebraically. Okay. Odd function. Okay. An odd function is going to have symmetry with respect to the origin, and we are going to prove it algebraically this way. Okay, so origin symmetry would look like this. Okay, if you fold your graph along the x-axis and then along the y-axis, then your graphs are going to match up. Okay. So this is what symmetry with the origin looks like. Okay. Algebraically, f of negative x is going to be the same as negative f of x. Why does that happen? Okay, if I have this coordinate xy, then it gets reflected about the origin to negative x, negative y. Okay, so this is where this is coming from. Okay. So we're going to look at some pictures first. Picture number 1. Is this an even or an odd function?
Even.
This is even. Why?
Symmetrical on the y.
It's symmetrical about the y-axis. Okay? Even or odd? Odd, because we have symmetry about the origin. Okay? Algebraically, I'm going to ask you to verify whether a function is even or odd. If I ask you to do that, then I want you to show me both the work for even and the work for odd. Okay? You're going to have a question like that on your text at the end of this chapter. I'll tell you that right now. Okay? So here I have a function, f of x equals 4x squared. Okay? How do we tell if it's even? Algebraically. What'd you write down? F of x is the same as f of negative x. Okay? Well, we know that f of x is 4x squared minus 2. And we know f of negative x would be, well, wherever there's an x, I'm plugging in a negative x. What does that simplify down to? Anybody? What's negative x to quantity squared?
X. So let's do.
So this is 4x squared minus 2. Okay? Since these are the same, then this would be considered an even function. Okay? Now we know that it's not going to be odd, but I'd still like to go through the work to show if it's odd. All right, so we can get that practice. If we wanted to show that we had an odd function, what's the algebra for that? F of negative x equals negative f of x. Okay? What's nice about this is we already know what f of negative x is. Okay? Negative f of x means we're going to do what with the negative?
Negative on the side.
Not just the 4. The negative has to go to the whole function. So that negative has to be applied to everything as a whole. Okay, so if we put a negative out in front of the function, we actually get negative 4x squared plus 2. Since those are the same, it's not odd, but we knew that that was going to be the case. Okay. I would still like you to practice showing both odd and even if you get one of them on the first try. Okay. Go ahead and practice both so you can practice that function notation. Okay. All right. So here is your homework. Okay, it's a pretty short assignment. To save us some time on Monday so we can do more examples in class, I'd like you to watch an 11-minute video over 1.6. Okay, you have a weekend. Okay, so you basically have 2 whole days until I see you again, right? Okay, so I want you to watch the 11-minute video, okay? That will save us some time on Monday, okay? And then after this, of course, you're also going to complete your survey for 1.5B, okay? So I'll have that posted here this morning, okay? When you have that written down,